Hello everybody, I am Alberto and welcome to a new training week by the Construct. In this case, this week is the Learn to Debug ROS programs week, where you are going to learn exactly that, to debug ROS programs and solve ROS related errors. Specifically today we are going to be starting from the basics and we are going to be debugging some basic ROS programs and working with topics, messages. You are going to find out right now. So if you are interested, stay here with me. So let's go. Hello there. So as I've just said, here we are again with another training week to help you stay safe in home due to this COVID situation. But stay safe, stay in home, but stay and keep pushing your ROS learning. That's always what you have to do. So here we are again in another week. As I've said, during this week we are going to learn to debug ROS programs. So we are going to be presented with different situations, ROS related errors basically, and with our ROS knowledge and the tools that ROS gives to us, we are going to find out these errors and solve them. Yeah, so this is all about this week. And today, as I've said, we are going to be starting with some simple ROS programs related to topics, messages, specifically working with laser messages. You are going to see right now. So yeah, if you are ready, I'm going to start now. So I hope everything is good. Let me have a quick look at the chat to see if everything is fine. So, all right. I can see here already many messages from Sankalp, Santi Swear, Richard Voice, Ibrahim, Der Kaput, Engineering Nation. Hello everybody and welcome. So as always, most of you, I imagine that you already know our philosophy. So we are going to start working with a project that I'm going to share right now with you. I'm going to put it here. I'm going to paste here the link in the chat so that all of you can get the project into your workspaces, into the ROS Development Studio. And meanwhile, I am explaining and working on my project. You can be working with your project as well and doing everything that I do. Yeah, so this is what I want you to do. I don't want you to be there just listening to me and watching me and listening what I explain, but I want you to practice with me. Yes, because by practicing is when you are going to really learn. Yes, not just by hearing. So let's go. Let me first of all get here the project so that all of you are set up and ready. So let me come here and get my link. All right, here I have it. And let me right now paste it to the chat. All right, so I have just pasted here the link to the chat. So when you get this link, just copy it from the chat and come to the ROS Development Studio. Let me switch right now to the ROS Development Studio window. So here we are. Then in ROS Development Studio, you just need to log in, of course. If you don't have an account created, it's free. So you can create an account within a few seconds. Then once you are logged in into the ROS Development Studio, you can paste the URL of the project right here, and the project is going to get copied here to your workspace. Yes? You're going to see it right now here in my workspace, and the project you are going to have is this one. Here I have 2 copies, so let me just remove one right now. So the project we are going to be working with today, it's this one. It's Learn to Debug ROS Code Day 1. Yes? Then, once you have your project, super easy. You click here on the Open button and Open Project. Yes, and this is going to start loading the project the project with all the files and ROS code, simulations, etc. that I have created. Yeah, so that you are going to have it with you as well. Yep, so good, so far so good. Okay, so meanwhile mine is here loading. Let me have a quick look at the chat to see how you guys are doing. Let me know here in the chat where are you watching us from. Are you from Europe, I don't know, Asia, India, from the United States? Let me know here where are you watching us from. Okay, so everything is okay, ready. Okay, ROS not found. It may have been removed. Please contact our support or the persons who shared the link with you. That's strange. Let me try this here myself. In my place. All right. So are you guys having problems with the project or project not found? Let me check this real quick. Okay. Okay, I think I might know what happened. So let me fix it real quick. Okay, so I'm going to share here a new project link, which is going to work for sure. Okay, so I have just shared here another project link. So get this one, the second one, I don't know, let me try to remove here this message. Yeah. Going to remove the first one, and I'm going to paste a couple of times the new one. Yep. Okay. So for some of you it's working. Well, anyways, for the ones who is not working, get this new link. Now it works. Okay, now loaded. Okay. Okay, so some people now is getting the project. Some of you are already loaded. So as I've said, get the project and start opening it. Yes. So that you reach this point here, yes? With the project loaded, you are going to have here automatically opened the notebook with the instructions that we are going to follow right now, yes? So I want you to, all of you, reach this point and wait for me to start with the class, yes? So this is the point that you should reach. So now I can see here, now it's okay, loaded okay, excellent. Okay, I can see also many people here. I can see some messages here, people from Canada, France, Uganda, United Kingdom, Germany, Brazil, Germany, Peru. Okay, so this is a very international live class, I can tell. Okay, loaded okay, working for me, this works. Okay, excellent, so it looks like everything is working perfectly. So yeah, let's go for it. Let's start. Let's go for it. Then, as I've said, once your project is loaded, you are going to have something like this, yes? You are going to have the notebook automatically opened with the following contents here, which I'm going to go right now, yes? Then, you should have this notebook here, the Learn to Debug ROS Code Day 1. Yep. Then, some basic requirements for this class, where you should have some basic knowledge of Linux, by the way, and also some basic knowledge of Python, yes? So these two are required. If you don't have them, you can come here with these links to our academy and do these courses for free. They are completely free, so that you can prepare with this knowledge for the following classes during this week, because you are going to need this, yes? So some basics of Linux and Python. So here you have the links in our academy. You are going to see these courses. You can start them totally for free. Yes? So there we go. Then, as I've said, this is what you have now opened in your computer is a project. Yeah, a project is what we call a ROS project, basically. Yes, but it has some very interesting features, like the one I have just shown right now, which is that you can create your ROS project with your simulations, your ROS programs, etc. Save it, and then you can share it with anyone you want, and they will get, just with an URL, as simple as that, they will get the exact same project that you have been working on. Yes? So you can create your ROS project and share them with your friends, with your colleagues, with your co-workers, with whoever you want. Yes? So this is basically a project. It has many more features. You can check here some links to learn more about projects. But now let's go to the point of this class. So the first thing is to set up the environment, which basically means to set up the simulation. Yes? So we are going, during the today's class, we are going to be working with two simulations. Yes? So we are going to start with a Turtlebot simulation, as you can see here. And then later we are going to also use another simulation with the same environment, but a different robot, which is this ROSbot. Yes? But first of all, let's start with the Turtlebot simulation. So in order to launch this simulation and to set it up, you need to come here to the simulations button here at the top bar. You can see it here. Then click here on the choose launch file button. And here you are going to have a list with all the launch files available on this project. And here you need to search for the Turtlebot Gazebo package. You will see it here in black letters. Turtlebot Gazebo package, and inside this package, you are going to select the debug day1.launch. Yes? So Turtlebot Gazebo debug day1.launch. Then you select this launch file and you click on the launch button. And this is going to automatically open a Gazebo window. You are going to see it right now, which is going to start and load the Turtlebot simulation that we are going to work with. Yes? You have all the steps described here in the notebook as well. Yes? With the package name, the launch file you need to choose, and the expected result, which is this one. Yes? So now, after some seconds, I should be able to see here a Turtlebot robot with a wall in front of it. Yes? And here I have it. Here it's finishing loading. Here there are some rendering issues, so I'm going to refresh this to visualize the simulation better. There we go. Alright, so here I have my Turtlebot robot, my dear friend, here with a wall in front of it. Yes? So this is the starting point for this live class. So all of you should have this right now in your computers. Yes? And maybe it's still loading the simulation, but we all need to reach this same point so that we can keep going and working together. Yes? So all of you should have the notebook here opened and the simulation opened and prepared to be used. Yes? For now, you are going to see here in the notebook as well the part 2 with the other simulation, but this part 2, ignore it for now. Yes? I'm going to come back to this later, but for now, just ignore it. Yes? And we are going to jump now to the problem to solve. Yes? So let me have a quick look here at the chat to see if all of you are doing good for now. I can see here working for me. This works. Loaded, it works. Notebook is empty. I can see here. I can see my colleagues are already answering you. So yeah, probably you need to wait a few seconds until the content of the notebook loads, Ibrahim. All right. So it is going to be 5 days long. Yes. Yes. So we are going to have classes each day during this week until Friday. So it's going to be a full training week, yes? Okay. Turtlebot loaded, simulation running, all good. Okay, great. So let me know if all of you are on the same page with the simulation loading. I can see that the comments here are telling me so. So if everything is good, I'm going to, first of all, before I start working, it's very important to get hydrated. So I'm going to get here a drink on my fancy cup of ROS developers. Cheers to all you. Okay, so now let's go back to work. Now I'm ready. I have the fuel needed to keep going. All right, so I can see all the messages saying that everything is fine. Okay, so let's go. Then here we have a scenario with a robot and a wall in front of it. Yes? Then here, if we read the following section, which is right here, the problem to solve, here it's telling us that this project contains one package inside its Catkin workspace, which is named Debug_day1. Okay, so how can I see my Catkin workspace here? Okay, so I can open a shell and check it from there, but I'm going to open an IDE window in order to see it graphically, yes, which is much more user-friendly, yes? So here, I'm opening my IDE where I'm going to see all the workspaces I have here available, and if I come here to the Catkin workspace, let me make this a bit bigger, there we go. Inside the source folder, I'm going to see here one package, which is named Debug Day1, yes? So I can confirm that the notebook is telling me the truth, it's not lying, yes? Then this package contains some Python scripts which contain basic ROS programs. So basically here we can see the src folder with two Python scripts. One is called detectWall.py and the other one is called moveRobot.py. Yes, so these are basically the two Python scripts that we are going to be working on during today's class. Yes, then the main purpose of this class is to be able to move the robot forward until it detects that there's an obstacle, the wall, which is closer than 1 meter. At this point, the robot will stop its movement in order to avoid colliding with the wall. Yes, so we have here the scenario that we are expecting. So the robot, when we launch our program, the robot should start moving forward until it detects that there's an obstacle, which is the wall in this case, closer than 1 meter. Then when it detects this, the robot is going to stop in order to avoid colliding, crashing against this wall. Yes? Which is something we don't want. So we don't want our robot to crash with something and get broken. Yes? Robots are usually quite expensive. So that's not something we want. Yes? So basically, this is what we want to reach. Then for this, in order to reach this, we have here one command that we can launch and that should start this expected behavior here. Yeah, we have here another GIF with the different robot, but for now we are working here with the Turtlebot. Then, how can I test this? So, I'm going to open a new web shell here, coming to the Tools menu here at the top bar, and opening here a new shell. Yes, this is going to open a new empty shell, which is an Ubuntu shell, where you can type any Linux basic commands. Yep. Then, what I'm going to do here is to copy from the notebook this command, Ctrl+C for instance, and execute this command here in the shell. I'm going to paste it here and execute it. Then once I execute it, what I would expect is something like this. So the Turtlebot robot should start moving forward, and when it's closer than 1 meter to this wall, it should stop. Yes, this is what we should expect. But let's try, let's see what happens. Let's see if actually this goes like this. So I'm going to now run this program and voila, nothing happens. Okay, so we are not starting right, yes? So if we run our program, nothing happens. Okay, so there are some things wrong here, yes, which is totally fine, yeah? So don't panic. If you execute this program, this command here, and nothing happens, don't worry, because this is the expected behavior, yes? So now we are going to come here to the scripts and start debugging in order to find out what's going on here, so why this is not working. Yeah, this is the work that we are going to do during this class, to see why this is not working. Yes? So, before I start here going inside the scripts in order to debug and see what's going on, let me have a quick look at the chat to see that all of us are in the same page. Yes. So this is the current status. Yeah. We have the simulation loaded. We have tested this command, which is here shown in the notebook, and nothing happens. So this program, this command is not working as expected. Yes. So this is the point I am currently at. So let me have a quick look at the chat to see how you guys are doing. Loaded. I have to say goodbye. Unfortunately, this time is for me not very happy because I have to bring my kids to their bed. See you tomorrow. Okay, so their kaput has to leave us. Okay, I'm sorry to hear that. However, you can, when this class finishes, we are going to upload, as always, the video, yeah, to YouTube so that you can check it. Yes, later at any time, tomorrow, when you have time, you can revisit and rewatch this video. Yep. So don't worry, they're kaput. Yeah, this DC Ballet says there are some warnings in the simulation log. Yeah, don't worry about them. So it's normal to, these warnings are normal, but they are not affecting in anything to the simulation. So don't worry, just ignore them. Yep, they are not important. Okay, I can see Sandy's where here saying error, package debug day 1 not found. Okay, in case you find this error, it's probable that you are going to need to source. Yes? So, in my case, I already have it, yes? But if your system is not finding your package, you need to execute this command here. Yes, you have it also above the other one, this source cutting workspace devel setup bash. Yes, so this command is going to set up your shell in order to detect all the ROS packages inside this cutting workspace. Yes, so if you execute this command here, now you are going to be able, or you should be able to reach this package. Yep, so make sure also to source your workspace with this command. Yes, very important. Okay, so apparently everything is going fine. So let's start debugging our programs to find out what's going on. First of all, any ideas? So what do you think? Do you have any clue of what could be happening here? Any ideas? Yes, no? So the first thing I can see here is that I am running the detectWall.py script. Yes, so this one here. Then this is the one that I'm going to open and start checking. Yep, here I have it. Here I have the script. The detectWall.py. As you can see, it's quite simple. Yeah, it's not a very complex ROS code. But here I have opened it in the IDE, so now I'm going to start checking this. But any ideas of what should I check first? What's going on here? What would you guys do? So one thing I want to also say, let me switch to my camera one more time. So I don't know if you already assisted the basic ROS learning week. We did a couple or 3 weeks ago. Yes. So during that week, we were doing also a training, but it was more a class, let's say, in the terms that I was explaining all the time new concepts to you. Yes. Then during this week, we want to do a different approach. So it's not going to be all that explicative. So we are going to assume some knowledge by your part. We are going to also provide some new knowledge, of course, but it's not going to be all the time explanation and explaining new concepts, etc. So it's going to be, I want it to be more interactive. Yes. So I'm going to be trying to find out ROS errors, ROS problems, but I'm going to be constantly asking you your opinion. What do you think? What should I do next? Yes. So I want to interact with you guys so that you give me feedback and you say me, hey, I think the problem is here. Check this. I think the problem is here, yes? So this is the idea of this week, to do a more interactive week, interactive sessions with you, so that between me and you, we are able to all together solve this problem and make the ROS program work properly, yes? So I wanted to say this as a difference to the previous training week that we did a couple of weeks ago, yes, which was more theory and new concepts all the time, yes, but this one I want it to be more interactive, yes. All right, so keep in mind this, I'm going to be constantly asking you questions and I want your feedback, okay? Then let's go back to our ROS development studio. I can see here disable check first the wiring of the nodes. Okay, yeah, that's a good idea. Put engineering nation says put some print statements into the Python file. Yeah, that's the rule number 1 in debugging. Yeah, so put some prints there and see what's going on. Check the topics. Okay, so I'm going to do a little bit of everything that you have said here. Very good suggestions. So let's go by parts. So first of all, let's check this script and try to understand what this script is meant to do. Yes, so here we can see some imports. So first of all, we are importing here the ROSPy module because we are going to be working with Python. We are also importing here a class from another Python script. Yes, so here I'm saying, hey, from this Python script, the moveRobot.py, import this moveRobot, which, if we come here to the moveRobot Python script, we are going to see that this is a class. Yes? This class, which is defined in this script, we are importing it here. Yes? So that we can use them within this script. Yes? I'm going to go back to this class later, but for now, let's keep going. So, next thing we have, here we are importing a ROS message, which is in this case a laser scan, yes? Because we are going to use it here. Then, here I'm defining another class which is called stop wall. Then, here in the constructor of this class, basically we are doing two things. We are creating a subscriber, by the way, this is redundant, so there we go. So here we are creating a subscriber, as you can see, for the Kabuki laser scan topic. And we are using here a laser scan message. Yes? And finally, we are setting here a callback for this subscriber. So basically, this subscriber is going to subscribe to this topic, the Kabuki laser scan, which is expecting to be receiving this type of messages, laser scan messages, and each time a new message comes into this topic, this callback here is going to be triggered. Yep, this callback is defined down here. We are going to check it right now. Then, below this subscriber, what I'm doing here is to create an object of the moveRobot class. Yes, so here I was importing it, and here I'm creating an object of this class, an instance of this class. Yes, so that I can use the functions of this class, which are defined here, into this program. Yes? Then, here I have the callback for this topic. Then, when a new message is published into this topic, this callback is going to be triggered. So then I'm going to come here, and I'm going to check here some value in this message, and I'm checking here if this value is higher than 1. If so, I'm going to set the linear x velocity to 0.5 and the angular z to 0. So this is the same as telling my robot to move forward. Yes? Let me get here a drink. All right. And then here, I'm using the moveRobot class. You can see it here. I'm using this object, the instance of this class, and I'm calling the send command function, which is defined within the moveRobot class. Here I have the constructor of this class, and the send command, yeah? So now, very quickly, let's review this script. As you can see, also it's super simple, yes? So basically, we are importing the ROS pipe model, as always, and we are importing the twist message, which, as you probably already know, these are the messages we use in order to move robots in ROS, yes? To send velocity commands to a robot. Then, here we are defining this move robot class, and we have the constructor where we are defining a publisher, which is going to publish into the command underscore vel topic messages of the type twist, yes? So I'm creating a publisher for the command vel topic. And then I'm creating here a variable, an attribute of this class, which is going to be of the type twist, yes? Then here I have one only function, which is send command, send underscore cmd, which takes here some arguments, linear argument and angular argument. So the linear argument goes for the linear velocity, and the angular argument goes for the angular velocity, yes? Then, depending on these values, I'm going to publish here the message into the topic, yes? So super simple, yes? This class is only for publishing a message into the command vel topic. Then here, I'm setting the values I want, which is 0.5 for the linear x and 0 for the angular z, and I'm calling this send command function from here, passing these values, yes? So that my robot starts moving. Then, if this message here, we are going to see now exactly what this means, is lower than 1, I'm going to set the linear and angular velocities to 0, and I'm going to publish them to the command vel topic. Yeah, so setting the velocities to 0 means to stop the robot. Yeah, so basically, if something here is higher than 1, I'm going to move the robot forward. If something here is lower than 1, I'm going to stop the robot. Yes? This is basically the general idea of this program. So it's super simple, as you can see. Yes? And the main idea seems to be right. Yes? So this seems to, it's similar to the behavior we want to accomplish here. Yes? So to move forward until the distance is lower than 1 and then stop. Yes? So it makes sense, this. At least the structure makes sense. Yes? Then, what is happening? So now that we know the program, more or less, what this detect wall program does and what this class does, where's the program? Why the robot is not moving? So, the first thing we can check here is, for instance, this value. What is this value? Yeah, because here I'm printing, I'm evaluating this value, but I have no idea of this value. Yes? So the first thing I can do here is to, for instance, put a print. Yes? So I'm going to set here a print. Later I'm going to modify this print to make it more ROS. Yes? But for now I'm going to leave it as a print. Then I'm going to print this, and let's see what we have here. Print message ranges 0, yes? So now I'm going to know what is this. Yes, so what is this value which I'm evaluating, yes? Then, let me save this and run one more time my program. So, I'm going to come here and ROS run debug d1 detect wall.py. There we go. And I can see nothing here. Yeah, so I can see nothing here. This is really... Okay, now I see something. Okay, this is strange, right? So sometimes I don't see nothing, sometimes I see something. This is really strange behavior. So does somebody know why this is happening? Because I have placed a print here. Okay, so the first thing I could check is if this topic really exists. Yes? Because I'm subscribing to this topic, then maybe this topic doesn't exist. So let's check this, first of all. How can I do this? With a ROS topic list. With a ROS topic list, I'm going to get a list of all the available topics. Yes? So here I have ROS topic list. And here I can see that the topic does exist. Kobuki/laser/scan. So the topic does actually exist. Yes? Then, next thing I can check. Is this topic really publishing messages? So the topic exists, yes, but does it contain messages? Because maybe if it doesn't contain messages, that's why I'm not reading nothing here, yes? So how can I check that? Well, with a ROS topic echo. So I'm going to subscribe here from the shell to this topic, and I'm going to see if messages are being published into this topic. Yes, with the ROS topic echo command. So with this, I can see that yes. So let me stop it. So messages are being published into this topic. So the topic is correct, the name of the topic is correct. Messages are being published, then the type is correct. How can I check if the type is correct? With a ROS topic info, Kobuki, laser scan. Yes, with this I can get information about this topic, and I can see that Gazebo is publishing into this topic, which is okay. So the simulation is publishing into this topic, and the message used is laser scan. I can see also this information here. So everything is right in with respect to this. Yes. So the subscriber is subscribing to this topic, which is correct, which uses laser scan messages, and this topic is actually publishing messages, so it contains messages. So if I subscribe to it, I should be able to see these messages. Then why here this print is not printing nothing? Why this is not working properly? Well, now it has printed something, but no longer. Now it prints nothing. So what's going on here? Does somebody know why this strange behavior? Sometimes it prints something, sometimes no, it doesn't. Let me stop right here, and I'm going to have a look at the chat and see what you guys are thinking. Okay, I can see some messages which are totally right here, yes? So I can see here, no loop in the script, ROS spin. It is missing ROS by spin to keep their node alive. We do not have a spin, subscriber doesn't update. Okay, yeah, so you are right, guys, you are right. So the problem is exactly here. So, what's the problem here? That this program is coming here, yes? So when I execute this program, I'm starting here, I create the node, yes, which is named like this, and then I create an object of this class, an instance of this class. Then when this instance is created, the first thing is to come to the constructor, yes, the subscriber is created, and the instance of the moveRobot class is created. Then a new message comes here, and the callback function is triggered. And then this happens. And then what? Then nothing. Then the program dies. Yes? Then there are some times where the subscriber is created and a few messages are published in that time before this program dies. So that's when I can see some messages here, yes? Because the program takes a little longer to die. Then I am able to visualize some messages here. But most of the times, as you can see, not now for instance I have been able to see something, but here I have not been able to see anything. In these cases where I don't see anything, it's because the subscriber is created, but then automatically after the constructor, I'm not calling anything, there's nothing else here, so the program automatically dies. And the program dies before being able to trigger this callback function. Yes? And that's why I cannot see any message. Yes? So that's why I'm having this strange behavior. Because this program is dying right after this line is executed. After this is done, this program dies. Yes? So sometimes I have time to see a couple of messages, sometimes I don't see anything, it's random, yeah? That's why it's behaving so weird. Then, what can I do to solve it? As many of you have said in the comments, the proper thing to do here is to add a spin. Yes, I could do this like this, rospy.spin. Then if I add this at the bottom of the program, this is going to basically stop the program here and keep it alive until I manually stop it. Yes, so this is going to be this kind of an sleep forever. Yes, so this is going to stop the program here, but everything is going to keep running. Yes, so it's going to be stopped here, but the subscriber is going to be alive, so the callback function is going to be triggered all the time until I manually stop the program. Yes, then let's save this and run one more time the program. Okay, so now I can see the value. Yes, and what I can see is that the value here is infinite. Yes, so the reading of the laser in this position is infinite. Yes, by the way, also you have seen how the, let me show it again. Let me stop the program and there we go. And all right, so now when I run my program, what happens is the following. Have a look here at the simulation. Let me come here and run the program, and now the robot does actually start moving, but it does not stop, so it crashes here against the wall. Yes, so the behavior has changed, but it's not correct yet. Yes, but at least we have been able to solve a first problem, which is this one. Yes, so now our subscriber is working properly and it's getting all the data from the callback. Yes, so next thing we should check. What do you think is the next thing we should check? Let me know here in the comments. Okay, I can see here some problems with the browser from Engineering Nation. Okay, I see that they seem to be solved now, so that's good to know. All right, laser ranges. Okay, we should not take range 0. Okay, yeah, so that are good suggestions. Yes, so here we are taking a specific message from the laser. Yes, but what is this message and why I'm using this message and not another one? Yes, because this reading is giving me infinite, which doesn't make sense. Yes, because what would make sense is that I get the distance to the wall. Yes, not an infinite value. This doesn't make sense. Then how can I debug this? Okay, so the first thing I can do is to have a look at a laser message in order to understand it better. Yes, so let me here have a look at one message. Here I'm going to just have a look at one message, and here I'm going to see some information about this message. Yes, then I can see here some metadata at the top. Here I have it. Yes, I can see here the angle minimum and angle maximum, which in this case are -157 and 157, angle increment, time increment, range maximum, which is 30. Yes, so this laser has a range of 30 meters. And then here I see the ranges array. Yes, here I have many values with all the beams of the laser. Yes, then I have many values, but how many I have? Yes, because here I am getting the 0 position, which is the first value in the array, which is this, That's why I'm getting infinite, because this first value is infinite. If I put 1, I would get also infinite, or 2. I can see many infinites. Here then I can see some values, and then at the end I see again infinites. Yes? So, what are all these readings? I mean, how many readings I have? And how do I know which ones I have to use? Which ones are the correct ones? Yes? So for this, the first thing I can do, for instance, is to print here. I'm going to do one very quick thing, which is to get the number of values I have in this array. I can do this using the len function. Yes? So if I come here and I do this, yes, I'm using the len function from Python with the message ranges inside. Yes, so if I execute this right here, let me do it. This is going to give me a number which is 720. Yes, so this means that inside this ranges array of the laser, I have 720 positions. Yes, and from these 720 positions, I'm getting the position number 0, which is the first one in the array. Yes, then how do I know which one I have to take? Because I can take any from 0 to 719. Yes, so how do I know which one I should take? Well, for this, you need to know first some information. Like, for instance, you need to know here this, the number of positions, but also the angle, the angle minimum and angle maximum of the laser. Yes? So, very quickly, let me come back here and reset this. ROS topic pub command bell. Let me stop it here properly and reset it. Gazebo reset world. There we, oops, sorry. World missing. There we go. Yeah. So here I can see that the angle minimum is minus 1.57 and the angle maximum is 1.57. Yes? So what does this tell me? Well, for this I have here an image prepared for you guys, which is this one, which I hope you already know. Well, not this one, but this one. Yes? So this is the P circle, let's say, yeah, the representation of the P number. Yes? Then, as you may know, as you already know, if not, pay attention to this. Yes? A full circle is equal to 2p. Yes, we have it here, which is the equivalent to 12p divided by 6, which is 2p. Yes? Then, half circumference, it's 1p. And a full circumference, it's 2p. Yes? Then, does this number remind you to something? This minus the 1.57? Yes, so this number is half pi. Yes? So the pi number is 3.14, etc. Yes? Then the half pi is exactly this. Yes? So p, let me write it here, notes.txt. Let me show it here better. So pi number is 3.14. Yes? I don't know if I can make these letters bigger. Spaces, plain text, maybe here. I don't know. Well, anyways, the P number is 3.14. Yes? Then P 3.14 divided by 2 is 1.57. Yes? And this 1.57, oops, sorry, I am still showing you this here. Let me switch back here to the ROS window, yeah? So here, the P number is 3.14, yes? Then if we divide this P on 2, we get 1.57, yes? So basically, the data I'm getting here from the message is that our minimum angle is minus P half and the maximum angle is P half, yes? So if we analyze this on this circumference, we can see that P half is here and minus P half would be here, yes? So we have here P half and minus P half would be here. So basically we have half circumference. So this means that the range of this laser is 180 degrees, more or less, yes? So half circumference, because it goes from minus P, which is this point here, to, minus P half to P half, which is this point here. And this traces half a circumference, yes? So now we can apply this to the following image, yes? So our robot, the laser would be 180 degrees, yeah? Half circumference, as we can see here, yes? Then, from this, we can know that the values at the beginning and at the end are going to be the sides of the robot, yes? That's why at the value 0, and also at 719, by the way, yes? So we analyze here the values at the beginning, here you have them, which are all infinite, and at the end are all infinite as well, yes? So this, let me show you here, yes? So this applies to this image here. At the beginning, all the values are infinite because there are no detections. And at the end of the array, all the values are infinite as well because there are no detections either. So the wall is somewhere in the middle of this array, yes? Makes sense, this? Do you understand what I have just explained? Does it make sense? Let me check here. Your comments. Yeah, okay, so I can see all of you are following and discussing about this. Okay, very well. Yes? Yes, Alberto. Okay, so from this analysis, we can deduce, yes, all this analysis, yes, from information of this topic, yes, so using the information that ROS gives us. Then from this, we can say, more or less, yes, that we should be checking the value 360. Yes, not 0, not 719, but 360, because this is going to be more or less the data of in front of the robot. Yes? So what happens here then? Let's test this. Let me go back to my ROS Development Studio here. So now I can come here and instead of this, I'm going to print message ranges on the value, let me come here, 360, and see if this makes sense. And meanwhile, so that I don't move the robot, I'm going to just comment all this very quickly. There we go. Yes? So now, in the callback, I have just left a print here of the value 360 on the message ranges. Then now I'm going to rerun my program and see what happens now. So let me do this right here. And now I can see a reading of more or less 2.5 meters, which makes sense. Yeah, if we check here, and each of these square meters are 1 meter, we have 2.5 more or less, which makes sense of these 2.5 meters. Yep, so this makes perfect sense. All right, excellent. So we know now that the value we should be using is 360. Then let's modify this here, update our code with the new value. There we go. Let's save this with the updated code. And now let's test it. So let's see what happens now. We can see the robot moving forward and stopping here exactly just in time before reaching here. Yeah, when it goes below 1 meter here, the robot has stopped in order to avoid the wall. Yes? Excellent. So we have been able to solve this. Then, all right, so let me think what to do, because we still have some things to check and I can see that the time is almost over. Well, I'm going to keep going, but yeah, okay, so let's do one other thing. Well, let me see if all of you have been able to properly solve this. Let me check here the comments. Yeah, so all of you have been able to solve this in order to make this code properly work. Have you all understood the process I have been following? Yes? Yep, I can see here that you guys seem to be following and understood the process I have been doing and explaining. It works fine. Says Francis Papamarinos. Okay, excellent. So, what else? What else? So we have solved here a couple of problems. Then another thing I want you to test right now is this move robot script. Yes? So here we have been using this script, this class, for this Python script. But now I'm going to be executing this by its own. So I'm going to come here and copy this main right down here. And test this by its own, yeah? So I'm going to add this here, debug day one node, okay? I'm going to name this move robot object of the move robot, yeah? So this could be another source of issues, yeah? If the robot is not moving, another thing we could check is that the publisher is working properly, right? Yes, so now we have been checking the subscriber, but imagine that the problem is in the publisher. So for this, we would have to check this code, yes, and if this code is working properly. Then for this, for instance, I want you to create here a main and create an instance of the move robot, and with this instance, we are going to call here, I'm going to remove the spin, and I'm going to call the send command function, yeah, in order to test this class. Yeah, all of this is in order to test that this class works properly. Then I'm creating the instance of the class here, I'm calling the send command function, and then I need to pass here some values. So the linear, I'm going to set it to 0.5, and the angular, I'm going to set it to 0.5 as well, for instance. Yep. 0.5, 0.5. Then, let me save this, let me reset here the environment. Reset world, there we go. Let me reset this, yeah? So I have now updated this code because I'm going to be testing only this code now, yeah? I want to debug this move robot py. Then I have added here some a main call so that I can test this by its own. Then here I create an instance of the class and I call the send command function giving values to the linear and angular velocities, yes? So now If I do this, well, let me give just a value to the linear velocity, which is going to be 0.5. Yes, so the robot is going to move, well, 0.3, better. Yes, 0.33 for the linear velocity and 0 for the angular velocity, so that the robot is going to move forward. Yes, if everything is working properly, the robot should move forward when I execute this program. So let me come here and execute this. So ROS run debug day 1 and move robot.py. Yeah, so now it's not the detect wall but the move robot.py. Yes, then let's do this and see what happens. Woo, okay, interesting. So I have executed the robot, I have executed this program directly and it's not working. Yes, so when I was testing this, which is using this same class, everything was working fine. But now I am testing only this and the robot is not moving. Yes, so I run here my program and the robot does not move at all. So why now it's not working? Can somebody tell me? Does somebody have an idea of why it's not working now? Yes, any hint, any idea of this? Let me know please in the comments. Okay, I can see some comments here related to movie and TFs, which we are going to have another day where we are going to discuss also about TFs and debugging errors with TFs. But today it's not the moment to do it. So, okay. I can see here Sandy's where. So is it advisable and easier to have that class present in both publisher and node? I don't understand this question, Sandy. I don't understand what do you mean. We don't send the command to the robot. Okay, so let's check this. Let's check what's happening. So this is supposed to publish a message into the command bell topic, right? So now if I do here a ROS topic echo of the command bell topic, now no message is published. But when I execute this program, a message should be published, yes? So if I run this program, the message is not published. Yes, so the message is not being published into the command bell topic. But why? I am publishing it here. Here I'm giving the values, I'm calling this function, and I have the publish here with the message. And when I call it this function here from the detect wall, here I'm using this same function, as you can see. And there it was working. Why it's not working now? Does somebody have any idea? Let me see. The last class you edited now should be present in both publisher and node. Well, this I have added here is just to be able to test this class by its own, yes? So when I call directly this function, this main is going to be activated, yes? If I don't have this main here and I call directly this function, nothing will happen, yeah? And here as well, here I also have here the main, so that I can call this file directly. Yes, otherwise, without this, it's just useful for importing it. Yes, but I cannot execute it by its own. So in order to be able to execute it like this, I need to add this main here. Yep. So let me see your comments, guys. Because we need to subscribe to the message. No, we don't need to subscribe to the message because somebody is already subscribed to that. Yes, if we have a look here at with the info message, I can see that Gazebo is already subscribed. Yes, and Gazebo is the one in charge of receiving the message and making the robot move. Yes, so let me do this real quick. So let me explain this real quick. So what is happening, basically, it's something very similar to what it was happening here with the subscriber. Yes? So here what is happening is that I am creating the instance of the class and I am calling here the send command function. Yes? But in order to have this publisher up and running and able to to send commands, it takes some seconds. Yes? And then right after this is created, I'm calling this function and publishing it. But the problem is that when I'm publishing, the publisher, it's not ready yet because it doesn't have time. Yes? So this is basically a problem, and you need to keep in mind this, that this is a very common issue with publishers. Yes? So when you create a publisher, it needs some time, I don't know exactly, but it's very short time. But for a program, it's a lot of time. Yes? For a computer, it's a lot of time. Then this takes some time to be generated. And until this is not up and running, and I don't have the connection to this topic, all the publishers that I do will be lost. Sorry, guys. Yes? So that's what is happening here. Yes? The program doesn't have time to publish. Then why here it was working? Well, because here I was publishing many times. Yeah, each time the callback was called, I was publishing. Yes, then maybe the first one were lost, the first messages were lost, but all the next ones were working properly. Yes, that's why here it was working properly, because I was publishing many times. Here I am only publishing one time, and when I publish this message, the publisher is not ready yet. So the message gets lost and the robot doesn't move. Make sense? Yeah? So what should I do to fix this? Okay, I can see here Thanasi says, so we need a ROS-PY sleep. Well, a ROS-PY sleep would fix it. Yes. We could add here a ROS-PY sleep. Yes, but a ROS-PY sleep, so for instance here I could put a loop while not ROS-PY is shut down, do this. Yes? And here it will be advisor also to put a rate. So rate equals ROS-PY.rate of 1 Hz, for instance. And then here I would add a rate of sleep. Yeah, so basically here I have added a loop. While I don't stop the program, I'm going to keep publishing messages, not only one, but many messages, yes, with a certain rate of 1 Hz. Yes, so with this, if I execute the program now, this is going to not work yet. Why? Because this is wrong. Okay, this is a mistake of mine. Yeah. So while not ROS-PY is shut down, while not ROS-PY is shut down, move robot send command, rate sleep. Okay, yeah. So let me call it now. There we have it. Yeah. So there we have the robot moving. Yes. So this has basically solved this problem. Let me stop it. But another question I want to do to you now. So okay, so creating a loop here solves the problem. Yes, because maybe the first message is lost, but the next ones are published and are received properly. But this doesn't solve the initial problem, because the first message is still lost. So what if I don't want to publish many messages, but I just want to publish one time? I don't want to keep publishing. I only want to publish one message, one time, and then stop publishing. What then? Yes? So if I only want to publish one time into the topic, not many times in a loop, then what happens? There, okay, I can see now a message from Wudong Hu. Check connections nums. Yeah, so there is a very useful tool in ROS, which is this one. Let me get the code very quickly and paste it here. And I will explain it right now. So let me add here a function very quickly. Okay, so here I have just added one function, as you can see, which is called publish once in topic. Yes? And what does this do? This checks the connections in the publisher. So if the publisher is connected to this topic, yes? Then this, I can do this with calling this function, the get num connections. Yes? These functions will return me the connections of this publisher that I have defined here, the self pub. Yes? This self pub I have here is the one I have defined here, which should be connected to the command bell topic. Then with this function, I can get the number of connections of this publisher. Then if these connections are higher than 0, so if I have at least one connection with the command bell topic, in this case, then I'm going to publish the message. Then I actually execute this command and I publish the message. Yes? Else, if not, if the connections are 0, so if the publisher is not yet connected to the topic, I'm going to come back to the beginning and check again. I'm going to check again this function. If it's 0, check again. And this is going to keep checking the connections of the topic until the connection is established between my publisher and the command bell topic. Then the message is going to be published and I'm going to exit the loop with this break. Yes? So this is going to allow me to publish only one message into a topic. Yes? Then here, instead of publishing, I have to call this function. So publish once in topic. Yes, so here instead of publishing directly into the topic, I'm going to call this super function, which is going to publish once I am sure that the connection is established to the topic. Yes, and it's going to publish only one message. Yes? Then let me test this right now. And let's execute here the program. Also, we can have a look here at the topic, ROS topic echo command bell. There we go. So I'm going to run my script. And for some reason it has not moved. Let me check here. Okay, yeah, I think let's run it one more time here. Okay, I think there's some issue now with the simulator. It appears to me that there's an issue with the simulator. Let me see, because that's not usual. Okay, there we go. Yeah, there was a temporal issue with the simulator. I don't know exactly what happened there, but let me stop it. And okay, restart this, and let's execute it one more time. And there we have it, yeah? So the command is published one time only, not many times, as it was happening before, one time only, into the topic and the robot moves. Yep. All right, so we are already 20 minutes past the time, so I'm going to finish right here. Let me have a quick look at the comments you are making, if there's any question or anything. Let me check real quick here. All right. Yeah, ROS spin ones. Some of you are suggesting here as well. Angel Jose. Okay, so is it clear? Have you understood this last part? Yeah? Make sense? Does it make sense to you? Any questions? Any comments? Yeah, Sandy Swear says we should have it as a 2-hour session. Yeah, indeed. At least this one has been longer than expected, and yet I haven't explained everything I wanted to explain. So there's still one thing missing, but it's going to be impossible. I don't know. Maybe I will explain it tomorrow, or I don't know. Yeah, for next days I'm going to have this in mind, because in 1 hour I really have to go to the point. Otherwise, I'm not going to have time to explain everything. Yeah. Matt Snowden says, thank you, really helpful. You are welcome, Matt. Thank you for these kind words. Everything okay? Yes. Okay, great. So, excellent. So, as you have seen, we have been debugging here some basic scripts. Yes, so with some typical issues that you can find when working with ROS topics or ROS messages. Yeah, so these are very typical issues. So now we have some more tools in order to understand this. Also in how to read and understand laser messages, which is very important as well, as you have seen. Yes. So okay, I'm going to switch here to my face in order to close this session. All right, hello there. I can see also another message here. As always, nice session, Alberto. Thank you very much. Then I can see are we get okay. Satya is asking, Sir, how should I start my practice in ROS? Well, Satya, I suggest you to go to the Ignite Academy. Yes. So let me come here and explain it very quickly. So my suggestion is you can start, for instance, here with the free courses that you will find here in the notebook by learning some basic Linux and basic Python. Yes, here in our Ignite Academy. And once you are done with the Linux and Python courses, which are for free, you can come here to the basic ROS course. You have it in Python, in C++, the one you prefer. But with these courses, you are going to get all the basics you need about ROS. Yes? So I suggest you to start here. I don't think you are going to find anywhere better to start learning ROS, sincerely. So I really mean it. All right. So let me switch back here. So thank you very much, guys. Already 22 minutes past the time I should have ended this live class. But anyways, I am going to see you tomorrow again. We are going to be covering probably ROS services. Yes, I'm not sure yet, but I think we are going to be working with ROS services. So stay tuned for tomorrow's class in order to learn how to debug ROS services and some particularities of ROS services, which are very interesting and that you need to know. And yeah, thank you very much for attending. Thank you very much for being with us in this week. We are going to come back tomorrow with more. Meanwhile, please stay safe, stay home, don't go out. We are going to try to provide to you content so that you can keep learning and working and practicing ROS from your homes. But stay safe, it's very important. We all need to stay safe, yes? And yeah, that's all. Thank you very much, and I will see you tomorrow. Bye-bye.